So hello once again. Today we are going to see about the C compilation process, how the C program compiles. We have already had some discussion regarding a C compiler. I'll give you a C compilation process. I'll give you a review about that first. The hello.c program was compiled using GCC and it was straight away given to the preprocessor. Preprocessor looks at your code and finds the files that start with hash, lines that start with hash. The lines that start with hash are the lines that the preprocessor will deal with. The preprocessor will see that you have given hash include in your program. So the preprocessor will include the file that I mentioned as a hash include file. The hash include file that we have mentioned is stdio.h. Here it is. Here is the hello.c program in which the hash include line includes the stdio.h. Now the stdio.h file will be pulled in from /usr/include where all the header files are kept. Okay, I'll show you that too. You go to /usr/include and you'll see all the header files are listed here. And from here, your header file that you wanted stdio.h is included in your program. Like this. The stdio.h say this is stdio.h, it is pulled in your program. So your program file now have contents from two files, stdio.h and hello.c. Okay, so such a file is called hello.i input file because this file becomes input to the GCC compiler. The GCC compiler is a two-pass compiler. It will parse your program twice. In the first pass, the GCC compiler will look into the program and identify all definitions and declarations, list all symbols in the symbol table. In the first pass, the compiler will look into your program, what all things are there that you have declared in your program, integer, char, float, or what are the libraries that you have used in your program, okay, inbuilt libraries, or what are the system calls that you have used in your program. All these things will be listed in a table called symbol table. A symbol table will be created where all the things will be listed. And if it is a library like printf, we have used printf is a library. So the library will have some kind of link also to the actual printf routine. Okay. Like this, the compiler will create the symbol table in the first pass of the compiler. Then in the second pass, it will actually start compiling your program. Wherever it sees that there is some IE or there is some printf, and it wants to know what is I and what is printf, it will refer to the symbol table. And in the first pass of compiler, you have already listed in the symbol table that symbol table will contain description about all the declarations. Now the second pass of the compiler will somehow compile the program and produce a hello.s file. The hello.s file is produced by the pass 2 of the compiler. Okay, actual compiler it compiles the hello.i file and uses symbol table to understand each and every declaration and definition. It produces hello.is, which is the assembly file. Here, this file is in a assembler form. This is further supplied down to the assembler. This is further supplied down to the assembler. Yeah. Assembler. The hello.s file is supplied to the assembler. This is assembly code. Supplied to the assembler. The assembler would assemble it, produce the binary executable file, which will be in the slightly different format. Let me rub this stuff which I have already written in the previous slide preview. Rubbing is a problem here. The rubber provided by Google is very small. Now it will be supplied down to your assembler. Assembler will produce an output file which will be called hello.o file, the object file. Okay. Now object file will contain your compiled code and many links to the libraries that you would have used. I told you earlier that a symbol table was also created. Symbol table was created which looked something like this, in which you had some entries about each and everything that you have declared and some links. Okay, these links linking to something called GNU glibc, GNU library for C programming, in which you will have all the C libraries, printf, scanf, like this. All the C libraries will be here. This link is one of the link to printf. Now the hello.o is collection of your compiled code and links to the libraries. Okay, hello.o. hello.o file is a collection of symbols. Okay, it contains please keep your microphone off. It contains compiled code, okay, and links to symbol table, and C libraries. Okay, these kind of things. Now it contains links, remember. Now this object file is further supplied down to your linker. So this is your next stage. Yeah, starting from the top, this is your C program .c, which is supplied to preprocessor, which will be further supplied to compiler, which will be further supplied to assembler. Okay, At every stage, it produces output files like hello.i, which is given as input to compiler, which produces hello.s, which is supplied to the assembler, which produces hello.o. The hello.o is further supplied to something called linker, which links all the files. What files to link? You have written your program, then you use printf. Now printf is linked through the symbol table. Okay, and the object file is a collection of symbols. It contains compiled code and links to the symbol table and C libraries. So these links are used by the linker to link various files. The linker is a program that links the various files like your source code file and various other files linkable, various other files whose links are provided through symbol table. Okay, so for all the files whose links are provided through symbol table, all those files are linked by the linker, and a final executable program is made available. Final executable file is made available. This executable file has a executable linkable format. Okay, it is called ELF format. This is the final executable file. Okay, same thing is explained here in a slightly different way. Now here it is, the C source file, okay, which is provided to you, is supplied to the preprocessor. This is the source file, hello world program, okay, where the hash, the directive hash include tells the preprocessor to include the code from the file stdio.h. Okay, this file contains declarations for functions that the program will use, like printf, scanf. Okay, ultimately final ELF executable linkable format file has to be prepared, and the whole C build process will go through preprocessor, compiler, assembler and linker stages. The C source file, source code file, will be produced stdio.h. There are a set of header files, many header files that are kept at /usr/include, I told you earlier. From there the stdio.h will be pulled into your program, and a hello.i program will be created, which will contain stdio.h and your hello.c both. Then after that, This will be supplied further down to the compiler. Now the compiler will start working on hello.i input file. Okay, the compiler will take the hello.i file as input and produce hello.s, which will be supplied to the assembler. Assembler will work on hello.s to produce hello.o object file. The object file will be provided to the linker, link editor, relocation object code information, and other object files, modules, and library files all will be linked together, and a final executable file ELF will be created. ELF file, executable linkable format file, will be created, which is executable code. Now this particular file that is prepared, the executable ELF a.out, this is resident in the secondary storage. Okay, the executable linkable format file, this file, the ELF file, is stored in secondary storage. Okay, now if you have to execute it, you have to bring it to the memory, RAM. To execute this file, it had to be brought into memory. How does it happen? Now suppose this is your executable linkable format file, which you have compiled just now, and you have made it available for execution, and it is stored in secondary storage. Okay, now you have to execute it. To execute it, you have to bring it in memory, isn't it? How do you do that? Well, here, to execute it, you bring it to the memory by doing ./a.out. You compile it using GCC. Okay, GCC -c hello.c will produce the object file. -c means compile only, don't link. So the .o file is created. See here. So this is another command that you will be using to compile only and not link. So here you can put it here. So these two commands have been given, and to produce hello.o, and from hello.o to produce the executable linkable format file, this you will give this command at this point. Okay. Now this is your ELF file that you want to execute, but it is resident in the secondary storage. To execute it, you have to bring it in the memory. So when you give ./a.out, then this program, which is resident in secondary storage hard disk, is actually pulled out from memory and pulled out from secondary storage and thrown into memory for execution. This is done by loader. Loader does this. Now this loader, about loader. It is a program that is part of operating system. It loads the program, means it loads some other program from secondary storage to memory RAM for execution. I hope you get that. So loader is a special program provided inside the operating system. The task of the loader is to take a program from secondary storage hard drive and load into memory or RAM for execution. Okay. When your program will come and get loaded in memory for execution, then your program will come from secondary storage into memory for execution and expand in memory for execution, like this. It will expand in memory for execution. Now this expanded space for your program in memory for execution, this expanded space is called process context. Process context. This is the footprint of the program in memory for execution. Okay. This process context is also called virtual address space, VFS, VAS, virtual address space. This process context or the virtual address space contains a code segment which contains compiled code. Then it contains another segment called data segment. Okay. Then it contains stack segment. Okay. So these are three segments that you will see that will be there in the process context virtual address space for execution. It will also contain three connectors numbered 0 and 1 and 2. This is the input connector and these two are output connectors. These connectors are connected to standard input, standard output, and standard error streams. These streams are data channel. These are software concepts, okay, which connect the standard input, output, or error devices connected with these file descriptors numbered 0 and 1 and 2. This is standard input stream, standard output stream, and standard error stream, which goes to error device. These are called file descriptors. Okay. Hold on. Now, about these segments. First of all, let us have a look at stack segment. The stack segment is used to store local variables. Stack segment used to store all the local variables. The data segment, the code segment first, contains compiled code. Okay, the code segment contains compiled code. Now the data segment contains global variables, static variables, external variables, register variables, volatile variables, macros, preprocessor constants, directives. All these things are stored in the code segment. The process context maintains offset from here to here, maintains complete offset. Okay, from say all zeros to some arbitrary great value. Big. Okay. These are offsets. This offset is called logical addresses, which are maintained inside the process context. Okay. So this is how the program executes. There is one more thing that is called task structure. Task structure, which is maintained by the operating system. Task structure. It is a kernel data type. Maintained by Linux operating system. Task structure. It houses all attributes and features, properties of the program in execution and the associated process context. Okay, so operating system will maintain all the information about the currently executing program, and all the information about the currently executing program will be maintained in a kernel data structure called task structure. This task structure file is found in scat.h header file. I will show you this in classes to come ahead. So this is how the program executes in C. Now we are going to start C programming. To start C programming, we'll need to know the programs are basically going to do some data processing. So very first thing we'll need to know is how is data stored and what are the data formats that are maintained in C program to store the data. For that we have to first learn data types in C. The data types in C are primarily categorized in three different ways, three different categories: primary, void, and secondary. There are three types of data types in C: the primary, void, and secondary. Under primary data type you have char, integer, and float. Okay. Under secondary you have many data types which are created from the primary. Like a table is a table. So I can ask you, what is this object called? You will say table, but I can say it's wood. So primary object is wood, and from wood you created the secondary object which was a table. So secondary data types are the data types that are created from the primary data types, like arrays, strings, functions, pointers, structures, union, enumeration, like this. Secondary data types are data types that are created from the primary data type. Now when we talk about char, int, and float, the char occupies 1 byte, capital B is for byte, integer occupies 4 bytes, and float also occupies 4 bytes. The computing system maintains a table called ASCII table. Okay, this ASCII table contains (256) characters, unique characters, and every character have a unique code or number associated with it. So there are 256 different codes. There is provision for 256 characters. So therefore the character is 8 bits, 1 byte, because to give 256 different codes it will need a binary of 8 bit. Okay, if you make it smaller, then you will not be able to see. What is this? What is this? Fine. So this table contains character, number, numeric code, character, numeric code, character, numeric code, character, numeric code, like this 250 up to provision for 256 characters and numeric codes. And every numeric code is 8 bit. Therefore characters is 8 bit. Integer is a 32 bit value, which looks like this. Integer. Let's have a look at integer. It is 32 bits. It looks like this. So these are bits. Bit number 0, 1, 2, 3, 4, then 31, 30, 29, 28, 27, like this, 0 to 31. Total is 32 bits. Every bit has a numeric value which is measured in the powers of 2's. 2 to power 0, this is 2 to power 1, this is 2 to power 2, this is 2 to power 3, this is 2 to power 4, like this. Last one is 2 to power 31, huge value. Okay. Whenever there is a bit here, binary 1, that will be considered 2 to power 4. 2, 4, 8, 16. Like this. Okay. Whereas the floating point has a different format. This is also 32 bit. It has 3 different fields. Total size is 32 bit. Which is further divided into 3 parts of 1 bit, 11 bit and 20 bit. This 11 bit portion is called exponent. This is called mantissa. And this is called sign bit. So this is used to refer to very small values or very big values, used to refer to decimal values. Right. So this is the basic introduction to data types. I'll give you more elaboration on floats later. Okay, let me give it to you. Suppose you have a floating point variable, okay, which has a mantissa, (20 bits), which has exponent 11 bits, and which has a sign bit. Okay, sign bit value could be 1 or 0. If it is 1, means it's a negative number. If you make it 0, means it's a positive number. Then how will you fill this 11-bit exponent and 20-bit mantissa is like this. Suppose you have some value. Point 0. This is some value. Now it is called floating point because this point will float and move here. It will become 6252.5 into 10 to power 1 because the point have moved here. Or you can say 625.25 into 10 to power 2. You can also write it here like this: 62.525 into 10 to power 3. Or you can write it like this: 6.2525 into 10 to power 4. Or finally you can also write it like this: 0.62525 into 10 to power 5. So this adjustment has to be done. The point has to be float and float and float and float and float it and bring it to the beginning. To maintain the value, you bring in the power. Okay. Now this power portion 5 becomes exponent and comes here in these 11 bits. Value is 5 means 1 0 1. This is your exponent, and this portion becomes mantissa. This is how the floating point values are adjusted, calculated and stored. Right? You got that? So this is how the C program and the data structures work. I already explained all this to you. \n is a escape sequence. We'll continue our discussion on \n when we start programming. Okay. So today I've just given you the basics about C compilation process, and this discussion that we were doing right now, all these this discussion, okay, this is shared with you through your mail ID. So I hope everybody is familiar with Google Drive. This will be available to you in your Google Drive for your reference. forever. Okay, and you will be able to see the recording of the session